Welcome. I almost said good morning. It's not morning anymore. So yesterday I did a whole class and I recorded it, but I was on mute. So that can happen, I guess. Doesn't happen often, but pretty annoying when it does. Anyways, I think on Moodle, I said that we were going to do some R basics, but I wanted to kind of keep talking about the theory of just simple linear regression, because it's good if we have a good foundation, and then hopefully I'll be able to just do a mini example of just a little bit of regression later today. Okay. And I also think I said that we were gonna install Python and kind of get started in Python in the lab. I might postpone that until next week because, well, I'm not prepared. That's why. No, I can be, I guess, but there's other things that I want to do. I'll just be honest with you guys. I'm not prepared to do that tomorrow. No, I checked, and I guess a lot of computers have Python installed already. And you can check that in the terminal. And if you're scared of working in the terminal, that's probably a good thing because it can really mess up your computer. But maybe that's what we should do now. Let me switch the screen because this is my iPad. How do I share this screen? This will stop. Yeah, so it seems to be, so this is how far I've gotten. Let's see here. Share everything, good, okay. So how I found, so I'm on a Mac, and it seems like Macs are pretty well the ones that it doesn't come pre-installed on. And so let's just check to see if you already have Python. You're gonna need to find the terminal, which is really scary to work in the terminal. And for me, I had to go to applications, and I had to go to utilities. And then here I have the terminal, okay? And if I open the terminal, it's gonna be this scary command line, okay? And what you do is you have a couple of options, but if you type in just Python here at the prompt, it should tell you if there is a Python installed and what version is installed. So I have Emily Gustafson $Python and enter. And I have an old version of Python. I have 2.716. Okay, so anything 2 point anything is not good. So I know that I'm going to need to install a fresh version. Now I'm holding off on doing that because I wanted to record while I do that. It's going to be kind of lengthy, me trial and erroring through, but that's how you check if you have Python available, okay, especially on a Mac, but similar scenario on a PC. And I guess if you have an HP computer, it's very, very likely that it came with Python. So just check that out. So for today, let's just see if you have Python, and if you don't, then we'll need to install it, but I'll make a video for you to work through. Okay, so the terminal is like the code for your computer. You do not want to be playing around in here. I mean, you can, but the terminal scares me. So I always make sure that I close it, terminate the terminal, and then I also make sure that I quit it. Oh man, yeah, if you guys like the terminal, I don't know what's wrong with you guys. No, it means that you're more skilled than I am. I'm so scared of the terminal. I've had to do some stuff in there and I don't want to. So I'm going to avoid using the terminal. You can absolutely apply updates and do cool stuff in the terminal, but for me it's a no. I don't want to. So I'll show you guys how to do it, hopefully without working in the terminal too much. Okay, so I want to switch back to my iPad. Stop that sharing. And now I know some of you guys are working in the terminal, just going crazy out there. Now I'll know who to ask if I have to work in the terminal. Okay, back on my iPad. What I'm finding is really nice about awesome about this course this term is we can kind of go at whatever pace we want. So we'll kind of pick and choose how we want to get through the material. Anyways, that's just me musing. So for you can check to see if Python is installed by opening the terminal by open the terminal. And I think that's the similar scenario for, it doesn't really matter if you're on a Mac or on a PC. And then after the $, write Python. It will return, oh, the command line, right? I think it's command, right? Thank you. Awesome. So it will return the version of Python that is available. It will return the version of Python that is installed, that is currently installed. Okay. If you have a version 3.0 or above, then it seems like you're all set up. Okay, so if the version is 3.0 plus, let's say, right, then you're all set up. Then you are all set up. If the version is below 3 or is older than 3, yeah, so it seems like they're at 3.10 right now. But from the documentation that I was reading, it was kind of like, okay, you'll be able to do all the normal things if you have 3 and above. So of course, if you do an installation now, you're going to get 3.10, and that's good. So if the version is older than 3, or if you just want to update it, that's fine. You will need to install the latest version. And I'm going to steal that it is 3.10. Okay. Oh, 3.10.2. I'll just keep it at 3.10. Thank you. That was good. Okay, so I will do that installation and I will record it, but you can probably figure out how to do it on your own. Okay, so I will do the installation on my computer. On a Mac. But at this point in the game, you guys should be pretty comfortable with finding the, just kind of going back and forth, not necessarily working on the opposite, but being able to figure out that, okay, computers are computers and they basically do the same thing and they work in the same way. So I'm going to do the installation on a Mac, and post the recording. But you will likely be able to just do the installation on your own. Be able to do the installation on your own. Okay. So, yeah, that's where I landed on that. Good. So the lab tomorrow is our first lab, and I think what I'll do is I'll just ease into it, and I'll post kind of an additional video with the Python install, but I don't think it's going to be that crazy. And so we'll probably just do some more regression in the lab tomorrow. Okay, but so today I just want to keep talking about some of the theory, specifically residual plots, right? We talked about them just so briefly last term, and so I think it's really good if we kind of get down to the nitty-gritty of it. And then yeah, so Windows 11, I mean, yeah, the installation procedure would be similar. You kind of go to the website. So if you Google Python, there's a Python probably.org is usually the extension. And then you would find the latest update, and then you just download it and install it just like you normally would. But it's possible that it's already installed and then you wouldn't have to worry about it. But who knows? But I haven't worked in Windows in a long time, but they're all the same. There you go. Hey, it is python.org. I knew it. I knew it. It's always .org. Thanks for posting that. Good. So I'll put that in my quick video. Hopefully it's quick. Good. So, all right. That's just because everyone was all gung-ho. So then I thought, oh, we gotta make sure we're all up and running, but I'll introduce it in due time. Okay. So, trying to remember. Sorry. Yesterday afternoon, I just started feeling like so sick, and I thought I would have to cancel today's class, but I took a Tylenol. So now I'm feeling better, but but I'm still kind of like, what was I gonna do today? Anyways, we're gonna do a little bit more regression and focus on residual analyses, the theory of residual analysis. That's kind of good for the Python end of things. Like I said, we're not going to introduce Python quite yet. But I also, did I show you guys RStudio Cloud? Did I yet? Can't tell. I know one I think at least one of you guys asked me about RStudio Cloud last term, and I was all like, oh, I haven't heard of it. And it is really new. So in my defense, but it seems like a really good platform to be using. And I've got it. Oh, nice. So you do use it. So what's nice about RStudio Cloud is everything is already installed. So for example, you can knit to PDF immediately, and you can also insert a Python code chunk in your Markdown document. Okay, so if you go, we'll just use this. It's resuming my project. I have a project working through numerical summaries for Stat 230, just like we did. And so it looks like this. It looks exactly like RStudio. But if you're having a hard time with kind of maintaining LaTeX and maintaining R and maintaining RStudio and now maintaining Python, you can avoid all that by using RStudio Cloud. So I am finding that it's a really kind of fun addition. Okay, and so one of the things that I noticed is that we usually use R code chunks, right? But another thing that you could do, and let's see if I can do it on my iPad here, is and it's kind of tricky, but if I insert a Python code chunk, it just knows that now you are using Python language. I don't know any Python language yet. It's very similar to R from what I've seen, but I want to make sure I know how to use it specifically. But here you're just kind of up and running. Okay, I know for you guys in data science, you are expected to have it up and running on your own computer, but it's just nice to have other options. Okay, so for showing on my iPad, I'm going to use RStudio Cloud, and it seems to be really good. So because before we couldn't use R on our iPads, or well, that was my only issue, I guess. Let's see if I can delete this though. Okay, so you should be able to just kind of work in Python even in a R Markdown document. So it is possible, and it's all set up and it's just up and running. Okay, so and it is, as long as you have an internet connection, you'll have everything installed. Okay, so kind of cool. It sounds like at least one person is using it already, so I'm glad to hear it. Okay. I can't remember if I told you guys, but one of the no, you can do it in on a local installation as well, but then you have to make sure that you have a recent version of Python installed. Right, so it's just, you have to make sure that everything is kind of installed and ready to go if you're working on your own computer. So sometimes it's nice to work in RStudio Cloud, so you know what it should feel like, and then you'll be able to accomplish that on your own computer. Whereas before that wasn't possible, right? We had to get you up and running on your own computer, and it was this kind of tedious thing. And I'm sure you guys felt so lost, right? Oh, you have to install this thing and then this thing and then this thing, and it's crazy. So with RStudio Cloud, you're just set up. It's just up and running. You can knit to PDF, no problem, right away, and stuff like that. I think so. So it should just be, you might have to install the libraries, but they should just be available. Everything should be just there. So that's kind of cool. Otherwise, we end up doing all these installations, right? But which is good just for long-term use. If you're using your own computer, it's nice to have it set up but sometimes it's just annoying. My LaTeX has wanted to update forever, and then I tell it to update, and then it just keeps complaining and telling me that I have an old version, and I don't know what to do about it. But it keeps complaining, and I keep updating, and it doesn't want to do it. So whatever. Neither here nor there. Okay. So check it out. For RStudio Cloud, there is a free account. I'm just working on the free account for now, but what I'm looking into is getting the instructor version where I could have you guys all join in on my workspace, and then you can use my instructor workspace as your own. And then what's nice about that, so the one benefit of that would be, and there are many others, but the one that I'm drawn to is that if you're having troubles with your R code, then I can go into your file and I can just see what's going on, and I can fix it and kind of manage it that way. And so that would be a real benefit, instead of you emailing me and trying to explain the situation and send me your file. I have to get your file up and running. It doesn't work, blah, blah, blah. So in terms of kind of helping you with your code, I think that would be a good setup to have. Yeah, also a Git repository. But you can link Git to RStudio, and specifically RStudio Cloud is already set up. I think for RStudio on your own computer, I've had it set up way back in the day, and I'm gonna have to brush off my Git skills. I think you guys, most of you know Steve Brown, maybe. And we were thinking of all these names that have Git in them, like Get Going, Get On Board, Get With It. Anyways, all those, can have some fun with it. Okay, anyways, me blah, blah, blah. Not in the terminal. I don't want to do it. Don't talk to me about the terminal. It may be easy, but it's scary. Anyways. Yeah, too scary for me. All right. Let's see here. Yeah, send me, how about an essay telling me how easy it is to work in the terminal? Anyways, I've tried to install, get Git installed and up and running through the terminal before. I went to like a seminar thing. I think it worked. I'm not sure. Anyways, whatever. I digress. There's also Git Classroom, which might be fun. Anyways, too many things that I want to at least introduce you guys to. But anyways, for now, let's focus on things I do know and that we should all know. All right, so I want to do, I want to call it assessing model fit using residual analysis. So once you fit a model, and for now, we're just going to focus on a simple linear regression. Let's break that up just so that we're really, really clear on what I mean by that. So simple, it doesn't mean, not complex. It means that there's only one value of X. So one input or explanatory variable. That's what we mean by simple, is that we just have one value of X, okay? And then the linear regression means that we're modeling the relationship between X and Y, right? So here, this is just one X. And then the linear regression portion means that we are modeling the relationship between X and Y, between X and Y by a straight line. Okay. So if we've done that and we've fit our model and we use the LM command, which I'll use in a bit, then each point is going to be some distance from the line. Okay? And so we can find the residual for each point. So once we have fit a line, can't remember how much of this is review from last day, but it's all good to stay on top of anyways, so that's fine. So once we have fit a line, we can calculate the residual of each data point, right, as the distance of that data point from the line, the model. We can calculate the residual of each data point as the distance between the observed value of Y and the predicted value of Y, which is the value of Y on the line. The predicted value of Y, which is Y hat, which is the point on the line. Okay. So a lot of this, we use kind of different terminology, but the line is the model, right? And so, but that feels like a lot of extra words in there, so I'm not. And then here, the line, sure, I'll add it, which is the model. Okay, because it models that relationship based off of the data. Okay. And so what we can do is, I'm going to try, if I go to my workspace and I start, hey, what the? I was just sharing my screen, right? Okay, and now it's gone. Uh-oh, what happened? It's saying I might need to reboot my device. Start broadcast. Okay. I don't know what happened there. Maybe my little iPad got overloaded. Try to go slow, maybe. That's always the solution, right? Just do it slower. Okay. I'm gonna try to pull up. So if I make a new project, and even if you were in my data science 300 class, we didn't really get to spend a lot of time working in R necessarily, but one of the things that you can do, especially in the cloud, but also locally on your own computer, is you can start these projects. So you can start a project, which usually when you close up, it'll say, do you want to save this workspace? And what it does is you can just open that project and it'll have everything that you need there. It'll import your data set and it'll save your file and it'll save kind of where you were at. And so that's kind of a fun feature. So in the cloud, they really push that. And so if you start a new project, deploying project. My poor little iPad. It's working hard today. Okay. I'm going to start a new markdown file. Uh-oh. Why is it thinking so much? Yes, I want to install those. It seems like I have to install everything all the time, and maybe I want, if I save it as a proper project, maybe I don't have to, but anyways, this is a new project anyways. What I wanted to show you was probably using the MT cars data set. It's a pretty classic data set that we use. I'll produce it to PDF and I'll call it simple linear regression. The author is me, so I guess just do that. And okay. So I am on my iPad here. Whee! I wonder if I can. Delete everything like that. Okay. So I'm going to zoom in here a little bit. And first thing I want to do is import, should be installed already, but import the, and if I use, no, I'm not really familiar with the MT cars data set. So then if I go down and I insert an R code chunk, then I think I should be able to save it as something like maybe car because it's easier. I'm gonna assign it to, maybe I need to pick up a keyboard for this little iPad because typing on it is a huge pain. Car is gonna be MT cars, which should, I might need a library. I'm gonna run this just in case. Run. Okay. So car, which is the MT cars data set, which is like a really common data set that we use. It's from like 1972 or something. Let's see here. Help. MT cars. If we look at the help for the MT cars, which is in the default data sets, so there's lots of data sets that already exist in R, so you don't have to import them. Yeah, the data was extracted from the 1974 Motor Trend US magazine. So it's very old compared to our cars now, right? But this is your code book, essentially, right? Because you're either taking Data Science 300 or you have taken Data Science 300, where you do have to create code books. And this is a version of a code book. And so the goal, right, is to just introduce what all you would need to know about the data, right, that you're about to use. So there are 11. Don't be fooled by the numerical, because they are numeric in the sense that they are all numbers, but they are not all numerical variables, right? So that there's a difference there. So the miles per gallon, let's see here. I'm gonna zoom out a little bit. Guess I can't really zoom out here. Okay. I'm gonna screenshot this and bring it in. We will work with the classic MT cars data set for our example. For our example, okay, it is already stored in the default data sets for R, right? So it is already stored as a default, I should say not the, as a default data set in R. Just type MT cars. Okay. If you look at, this is essentially a code book. Okay. Now, don't be fooled by this numeric. What numeric means in this case is all are stored as numbers. That's really common, right? If you have worked with any dummy variables before, I'm assuming that we haven't, although I know a lot of you have. But as a nice kind of jumping off point, let's assume that you have not worked with dummy variables. Then we'll be better for it, right? More review. So all are stored as numbers, but not all are numerical values or variables. Okay. So if we go through these here, miles per gallon is a numerical variable, right? The number of cylinders, I think you can have 4, 6, or 8 cylinders, right? Those are numbers, but they are categories, right? Because it doesn't make sense to talk about the average number of cylinders, right? Remember, that's your check-in point. Does it make sense to talk about the average? Not really, because you can't have a 5-cylinder car. Maybe you can, but they just don't exist, right? And so here, this would be numerical, and this would be categorical. Okay. The displacement seems like as soon as we have units, cubic inches, that's kind of a giveaway that it's going to be a numerical variable, right? And maybe what I'll do is I'll copy this and just we'll go through and we'll, oh, maybe not. Won't let me do it because I'm already on a picture. So here we go, numerical. Gross horsepower. That would be a numerical variable, right? Because it's a measurement. And so that's numerical as well. The rear axle ratio seems like a numerical measurement. I'd probably have a look at the data, but because it's a ratio, I don't think that there are different categories. I think that it's going to be numerical. It's not one of the variables that we're going to focus on anyways. We could, but probably won't be that interesting. The weight is also numerical. Quarter mile time, time should be numerical, although it's kind of a special unit. Engine, 0 means it's V-shaped, 1 means it's a straight engine. I don't know anything about engines, and that doesn't really matter. So one of the main things that kind of stops people in their tracks when they're first learning statistics is, well, I don't know anything about economics, or I don't know anything about cars, or I don't know anything about basketball. And that's fine. It makes it harder, right? It makes it easier if we know something about, what's reasonable in the data, but it's not, we don't need to know everything about the data. Right, so here, just knowing that, okay, a 0 means it's V-shaped and a 1 means it's a straight engine. I don't really need to know more than that, right? There might be scenarios where you might be, if you know the difference between those two, then it might be easier to say, oh, that makes sense. Or if you find something interesting, you might have to find someone who knows about V-shaped versus straight engines and ask them, hey, this is what I found. Does that make sense? Right. And that's going to be the case for any project that you work on. So don't put too much pressure on yourself. And it's hard to know everything about, the data that you're looking at. Your job is to find things and then see if anyone finds it interesting. So the engine is categorical. The transmission, 0 means it's automatic, 1 means it's a manual, so that's going to be categorical as well. The gear is the number of forward gears. Now, here's where I think we could maybe argue it either way. Does it make sense to talk about the average number of forward gears? Yes. Are there only so many, right? So we could treat them as categorical. Yes. I would say probably let's treat it as numerical. Numerical, or it could be categorical. If you wanted to argue that you wanted to use it as a categorical variable, but I would probably argue that it's numerical. And that happens a lot, right? As long as you stick to your guns, okay, here's what so here, I want to say, I'll put a little subnote here, numerical. I will treat, and this is what I want you to do as well, right? If you're making this kind of, so far, all of these have been pretty obvious. I don't think anyone would question it if this is what you landed on, numerical, categorical, blah, blah, blah. But if you find yourself kind of making a decision, right? Deciding if you're going to treat it as numerical or categorical, and you could have been persuaded either way, then you should probably bring the reader into that, right? And say, and just explain why you made the decision that you made. So here is just an example of what I want you to start to think about, right? If you made a decision, then explain that to, well, in this case, I'm your reader, so explain that to me. Explain what your thought process was. And as long as your thought process is good and logical, I can't argue with that. And I won't argue with that, right? I'll just say, okay, good. So I will treat the number, the number of forward gears as a numerical variable, right? And remember, the argument that I'm going to use, and I expect you to use as well, is if you're treating it as numerical, then the argument would be because it makes sense to talk about the average number of forward gears. Okay. Since it makes sense to talk about the average number of forward gears. If you disagree with me, then what are you saying? Then you think that it's a categorical variable, and that may very well be, but I have buttered my bread, so to speak. The number of carburetors, I don't really know about carburetors. I know they can break, but that's about it. So the number of carburetors, I think there's probably only a certain number. And again, it could be categorical or it could be numerical. In this case, I'm probably leaning more towards categorical, right? But numerical or categorical. I haven't really decided. It's not a variable that I'm going to focus on, so I'm actually going to ignore it for now. Okay, so that's the data set. There's 11 variables, and I think there's how many? 32 observations. Very small data set. Okay. Okay, so my analysis, if I only have one response variable, which is always the case, but then I'm only considering one explanatory variable, I'm going to have to pick those two very carefully. So the classic example would be, does the, well, there's kind of a couple of different examples, but let's say we want to focus on the weight of the car and the miles per gallon, right? Does the weight of the car affect the miles per gallon? Okay. So our analysis will consider whether the weight of a car, whether the weight, which is the WT of a car, affects its miles per gallon, or its fuel consumption, let's call it. It's, sorry, fuel consumption. MPG. So what I'm looking at here is I have the weight is my explanatory variable, and my miles per gallon, my fuel consumption, does it affect the fuel consumption? That's going to be my response variable, which is my y variable, which means my explanatory variable is, of course, my x variable. Okay. see my screen there. Okay. So first thing I'm going to do, make sure I don't lose my shared screen here. Okay. I'm going to close that up, and I've imported I saved my cars. I made an object called cars, or car, I guess. And just for visual car, I'm going to make a plot, and I'm just going to use the basic plots. I know you guys are all ggplot whizzes, and you have been working a lot in ggplot. I know that. But for simplicity's sake, and for just getting a quick look at stuff, I tend to use the basic plots, and that's fine. They just don't look as good. So the plot of, now, it likes to do x equals y equals, but to make it match the linear model command, I'm going to use y tilde x. Okay. And so I've got my shoot, I should be able to say data equals car, or empty cars if you don't want to save it as an object. But I'm going to go old school here and say car $. This is really old school though, but I just want it to work. I don't want to play around with it too much. So car $MPG. Oops, helps if I type it right. I did it again. MPG. And then I want the tilde. So that's the y tilde x, which is car $. And I think we said wait, or I know we said wait. And if I run that, I get this plot. I wonder if I can scoot this down and keep that there. Bring that in. Nice. Wait. You know what? Let me crop this up. Crop here. And maybe here as well. Okay. So to make a quick scatter plot, as long as you're not trying to publish it, so as long as it's not part of a fancy report that you're writing or submitting it to a client, I would say don't waste your time with ggplot unless you feel super comfortable with ggplot. But and the only way to get comfortable is to work with it. But if you're just trying to figure things out on your end, then base plots are way quicker, I think, at least for me. But depending on what you want, use plot y tilde x, right? Or you can use plot x comma y. Okay, but I prefer this one. I prefer this since it matches my LM command. Since it matches the LM command later. Okay. And I'm not going to make a note of it, but car $MPG tilde car $WT is pretty old school, but I wanted it to work. Okay, so if we see this relationship, so now we have a pretty good idea. It looks like there is a relationship here, right? In fact, it looks like a negative, a relatively strong negative linear relationship, arguably linear, right? There might be some curvature here, but I would say if I fit a straight line here, it would do a reasonable job, right? And so, and most of the time, even if we fit this crazy model, a linear model might have worked just as well. And in this case, this would be one of those cases. But we see the relationship between MPG and WT. We see the relationship between MPG and WT is I don't know, I'm going to go with strong, is a strong negative linear relationship. Is a strong negative linear relationship. Good. So I'm going to fit the model. Okay. So I'm going to call it, I usually end up calling it something silly like mod 1, mod 2, mod 3, mod 4, because in the end, we would probably end up building many models. Okay? But for now, we just have the one. And so because we only have one explanatory variable, so we're going to keep it nice and simple. Okay. So I'm going to fit the model. Hope it pulls up here. Okay. And see if I can close this. Oh, there. Oops. Now fit the linear model. I'll post this R code. Oops, that doesn't say model. After class, but for now, just insert an R code chunk. And that's where you would be able to change it to be a Python code chunk if we wanted to. So fit the linear model. Here we go. And I'm going to call it, I'm going to store it in an object called mod. Very original. Is going to be LM, and typing on this tiny keyboard is so annoying. And I realized yesterday I couldn't copy and paste like I usually do. So car $MPG. And now we need to use the tilde. So it has to be a linear model of y tilde x. Now, that's going to come in handy later, because if we have more than one explanatory variable, then we would have y tilde and then all our x's tacked on at the end, right? But we're going to go nice and slow here. Car $WT. And again, you could use things like data equals car instead of having car $. I know, but like I said, I just want it to work. It's because I was burned yesterday. I was playing around in class, and which is good, but everything took longer than it should have. Oops. Hey. There. Okay. So now I have this mod, and mod stores things like the coefficients. Let's see here. The coefficients, the residuals, the effects, the ranks, the fitted values, a sign, I don't know what that is, QR, I don't know what that is, that's okay. The degrees of freedom of the residual, the X levels, the call, the terms, the model, and the attributes. That's a lot of stuff, and very little of it is stuff that we're gonna need. Okay. So if I do a summary of mod, oops. Then I can run that. And it gives it to me there, so I'm gonna go bump this down. Okay. And I screenshot this. Done. Bring it in. Crop it up again. Okay. So it tells me what I told it to do, and that's probably a good thing, because otherwise you might not remember what you told it to do, and maybe it wasn't what you meant to tell it to do. So that's good, just as a reminder. And then it gives us the 5-number summary of the residuals. Now, usually we don't really pay attention to this because we're going to dive deeper into the residuals later. Okay, but so here, just to kind of break things up here and tell you so that you can just start to work through, this is just tells you, or maybe I should say reminds you, what you told it to do. Okay. Nice for checking. Now the residuals, this is a 5-number summary of the residuals. The residuals should be centered on 0 and be relatively normal. But this is a good kind of check-in point. I usually ignore it though. I completely don't look at this. I just go straight to the coefficients typically. Okay. But it's there if you wanted to, but it doesn't cut out the need for a residual analysis. So that's why I don't even bother. Okay. So I usually ignore this. Sometimes it's nice to know what you can ignore, kind of ignorable warnings or ignorable output, so that you can just focus on what you're meant to focus on. And that's hard in the beginning, especially if you're not used to reading output like this. But I usually ignore this since we need to do a more thorough residual analysis anyways. Right? It could be part of it, but it doesn't have to be. Okay. So from here, what I want you to focus on for today is we just need to grab the coefficients. Oops. So from here, what this is saying is that MPG hat is 37.28, I guess 5.1, let's do the whole thing, minus 5.3445 times WT. Right. In general, y hat is the intercept plus the slope times the x. right? But now we have the variable names, so we may as well use them. So how do we read this? The predicted miles per gallon is 37.2851 minus 5.3445 for each unit increase in weight, right? So the miles per gallon, the predicted miles per gallon is decreasing for each unit increase in weight, right? So we can use this to predict future values. Now, what I want to do is I just want to fit this and then we're going to save this output. Only some of it we pay attention to. Pretty much the multiple R squared is the only one we really pay attention to, but we're going to talk about all of them at a later date. And this. So here I'm going to say save to talk about later. How about that? I know we mentioned it briefly, but in this course, we're really going to talk about it a lot. So that's why I'm kind of like, we'll talk about it a lot later. So we'll dive into that and we'll kind of dissect it and pull it all apart. And it's going to be great. Okay. So what can I do? I can add, okay. Close that. So now I can add the linear model to the plot. And how do I do that? Oops, keep hitting the down. Anyways, insert an R code chunk. And I want to, how do I do it? I think it's ab line, AB line of mod. Can't see. Oops, it's this side. I think, and now I'm just kind of going by memory, but that's okay. Should work. Usually what would happen is, so you need to have the most recent, so the plot has to be available, usually kind of old school, I guess. It would just put the line of the model just on whatever plot was most recently produced, but it seems to need the actual, so that's fine. Because I can't figure out quite yet how to copy and paste with my pencil. It just wouldn't let me do it before. So car $, MPG. So I'm just going to generate the plot first because that's what it's complaining about. Car $, weight. Okay. And now if I run the current chunk, it should just do it. Okay, and so that would be the line that we fit. So that is the model. Save. Crop, crop, crop. Okay. So now each point is going to have a residual. Now the residuals are stored in the mod object. Okay. So here we see that each observation will have a residual value. Right, EI, my donkey, EI is YI minus YI hat. Okay. So it's the observed minus the predicted value of Y, and the predicted value of y is on the line. Now, all the residuals have already been calculated, and are stored in the mod object. Yeah. So what we can do is we can access it, use mod $, residuals, I think it's plural, to access the residuals. So I keep forgetting that it clunked out once when I go too fast. So now I find the residuals, and I think it's easier if you append them to your data set, and append to your data set. Can't see what I'm typing, but looks good enough. Okay. So what I'm going to do is first I'm going to pull up mod $, and here it gives me the options of the coefficients, the residuals, the effects, the rank. So it has a lot of values. And so let's have a look at the residuals. And if I run this, oops, that's kind of boring. It gives me the residuals, but if we look at it like this, so now I'm going to attach the residuals to the car data set. So now what I'm going to do is I'm going to create a new column on car. So what I do is I say car $, resid, maybe. Oops. Is assigned to the mod $, residuals. So what you're going to find is that it's going to be, and what, before I do that, how do I get rid of this? That's just bouncing around. Okay, there. I'm going to tap that up there. Okay, so now the car data should go from 11 variables to 12 variables once I run this. So if I run this, now I have 12 variables, and at the end I have the $ resid, and that's how I'm going to be able to access and plot my residuals against other values in the original data set. Now, just for fun, it might be nice to have the fitted values as well. Now, the fitted values are the predicted values. So let's add those on as well. So car $ fit, let's do fitted, unless it's reserved, we'll find out soon enough, is going to be holding mod $ fitted values, fitted dot values. And then I'm going to run that. And now it's added to the car data set there. Okay. So hey, time flies when you're having fun, I guess. I kind of knew this would happen, so I'll just continue the residual analysis. It was wishful thinking that I would get there anyways today, but I'll just continue it wherever we end today. I'll continue tomorrow for the lab. Okay, So now, right, what I wanted to say was that the fitted values are the predicted values. Okay. And so notice that now the car data has this $ resid and $ fitted, which I have added to the data set. I want to go back and I want to look at the car data set. Okay. And how can I make it larger? I can't seem to bring it over. How can I, oh, maybe like this. Oh, allow. Okay, good. That's what I wanted. So now, looks like you can do cool stuff like filter in here, but I've never played around with that. So what I want you to try is just confirm the first few fitted values, fitted or predicted values, using the model that we built. Using the miles per, oops, I keep writing MGG, but it's MPG hat is, hey, it was in the same color too, 37. Yeah, I'm just gonna copy it. How about that? Okay, so what you would do is you would take the weight of 2.620 and plug it in here and just make sure that you get a predicted value of 23.28. And that's just to confirm that you've appended it to the right values. Should work out, but I'll let you test it out. I really hope it works. It will. But I'll pick up here for the lab tomorrow, which will just be a recording, and we'll keep working with these residuals for the residual analysis. Let me know if you have any questions. Otherwise, I'm going to stop this recording, and I hope that you have a great weekend. Stop this here.